Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 1 and 2 class. We are continuing here with polynomials. We have learned already how to add, subtract, multiply, divide polynomials. We know how to factor polynomials. We know how to factor four-term polynomials by grouping. We know how to factor out a GCF from any polynomial. We know how to factor out trinomials where the coefficient a equals 1. We know how to factor out trinomials where the coefficient a is greater than 1, or actually the absolute value is greater than 1, it's just other than 1. We know how to graph special cases, perfect square trinomials, difference of squares, sum of cubes, and difference of cubes. So now that you have all of that, I'm going to show you why it is that we actually factor. What is the point of this? But before I can really do a good job of this, my friends, I'm going to have to go back in time just a little bit. I want you to make some connections here, and it's really important that you see what I'm trying to illustrate. If you don't see the connection, guys, I need your honesty. I need you to tell me, Morrow, wait, I'm lost. I don't get it. Okay, we need to make these connections. So, we already know that linear functions are in the form of y equals mx plus b. Our midterm is coming up, so just a friendly reminder. Remember that y is the dependent variable. It depends on x. X is the independent variable. M is my slope. Thank you very much. Remember that slope is the rise over the run, and the equation is y2 minus y1 over x2 minus x1. And remember that b is my y-intercept. And that is the y value on the y-axis when x is 0. Okay? Everything I just said has all been described right here. We know that already. Notice, though, that the degree of the polynomial here is a 1, okay? The degree of x here is 1. When the degree is 1, it is linear. Again, all of this we know. And then I have a bunch of different linear equations here. And actually, I should make this proper graph by going x and y so you know what the graphs are. Okay? The green guy, that's a linear equation. That's y equals 1, 2, 3, 4, 5, 6. Okay? The red is x equals 1, 2, 3, 4, 5, negative 6. The blue line here, this guy is a negative slope. Okay, the black line here, that's a positive slope. Okay, remember that linear functions are straight lines. Okay, you with me there so far? Everything's good? All right, and remember that solutions. Okay, remember solutions are the intersection points. So the intersection point between the black line and the green line is right here. Okay, that's the solution of that system. If it's between the green and the blue, that's the solution of that system. If it's between the blue and the black, that's the solution of that system. Intersection points, okay? So all of these are just linear, just some reminder of what linear is. Remember, linear, the degree is 1. Linear, degree is 1. Now, quadratics. Quadratic functions are in the form of y equals ax squared plus bx plus c. Please, my friends, please remember the following. This right here is called standard form. There's a few different forms of quadratics. We're going to have a chapter, I promise you, dedicated solely to quadratics. A whole chapter on it. It's a fun chapter. We're going to graph inequalities, regular quadratics. We're going to solve them, write equations. I can see people are really excited as I see the people doing the high fives and stuff. Okay, so this is a quadratic. We know it's quadratic because x is squared. The highest degree is a 2. Okay, guys? So this is where y is dependent, of course, x is independent. A and b are coefficients, which we will investigate later, I promise. And c is the y-intercept. Notice that the degree of the polynomial is 2. Remember, the degree tells you what kind of a polynomial it is. Remember, we went over that. degree 1 linear, degree 2 quadratic, degree 3 cubic, right? Degree 4 quartic, degree 5 quintic. Very good. So we're all good so far, right? All right. Now let me show you what I'm doing all of this craziness for. Quadratic functions render parabolas, my friends. And parabolas, as you can see, are U-shaped graph, okay? I promise you, I will show you how to do this detailed. Right now, we're not worried about graphing, I promise. I just want to show you the graph so that you can understand what we're doing with factoring. When you have a parabola, okay, like this equation right here, it's y equals x squared plus x minus 3, okay? If I were to solve this equation, or graph it, I get this line here, not a line, I get this shape. This shape, this parabola, crossed the x-axis here and here. My friends, that's what we're looking for today. You factor out trinomials so you can find their factors, and then we're going to apply something called the zero product property. And the answers that you get are these two green dots right here. The solutions to a parabola, to a quadratic function, are basically the x-intercepts. So in this graph over here, I had this graph. This u is pointing down. You'll find out later on that it's pointing down because the a is negative. But it went through negative 6, and it went through positive 4. So the solutions of this quadratic equation are negative 6, x equals negative 6, and 4. So when you graph a parabola, and it intersects that x-axis, it goes through that x-axis, those are the solutions. I'm not trying to be sarcastic or anything like that, guys. I just want this to be really clear. Because now we're going to be doing some heavy math. And people do the math, and they're like, hey, okay, well, the answer's 5 and 9. Well, what does that mean? Well, I don't know. I just did what my teacher told me to do. Well, now you know what we're finding. We're finding the solutions of the quadratic equation. And the solutions of a quadratic equation, once again, my friends, are the intersection points of the graph with the x-axis, so the x-intercepts. Remember that the x-intercept equals the x value on x-axis when y equals 0. So conceptually, can you see what I'm talking about so far, my brothers? Yes? No? Maybe? Kind of? Sort of? Okay. So what did I write here? The points at which the parabola crosses the x-axis are the solutions of the quadratic function. In other words, the x-intercepts are the solutions of the quadratic functions. So we know now, when I say find the x-intercepts of this quadratic function, you are finding the solutions. Very good. Okay? Now, how does this work? Sometimes we can find solutions of quadratic functions by factoring and using what's called the zero product property. Let's first teach you the zero product property. The zero product property states the following. For any real number a and b, if a times b equals 0, then a equals 0 and or b equals 0. So what does that mean, Mr. Morrow? Well, if I have the following factored out trinomial, I have x plus 3 times x plus 2 equals 0. X plus 3 is one factor. X plus 2 is your second factor. You have to set each factor equal to 0. I don't care if you have 2 factors or 47 factors. Each factor must be set equal to 0. So in this case, I got to set x plus 3 equal to 0 and or x plus 2 equal to 0. And then when I go ahead and solve that, x will equal, in this case, negative 3 and negative 2. That means that on a parabola at the -3 and the -2, the graph goes through at those 2 points. I want this to visually make sense to you. I want you to understand why and what we are doing. Not just how to do the stupid math, but what is the point of this? Does everyone see that so far? You promised me, guys. This is really important. I want to make sure you really got this. Okay. So now I'm just going to practice the zero product property with you, and then we'll put it all together. So if I told you already, what are the solutions of this equation? Well, they already factored the equation for you. In this case, you have one factor here. This is your A times B, your second factor. Zero product property states that A must be set equal to 0 and B must be set equal to 0. So to find the solutions here, you're going to go 4x plus 1 equals 0 and x minus 2 equals 0. So I'm going to solve for x. I know you know what you're doing. That's why I'm not really discussing what I'm doing here. And then I add 2. So x also equals 2. So in the end, my solutions here are x equals -1/4, comma 2. And again, what does that mean, Moro? Who cares? That means that on some parabola, at the 2 and at the -1/4, that parabola is intersecting those 2 points. Does that make sense, guys? You have no idea yet how to make that parabola. I get it. We're going to get there. But do you understand what factoring does? Factoring breaks it up into its factors. You set each of those factors equal to 0. Those are your x-intercepts. Those are the points that the graph intersected or went through. I'm not trying to be a broken record. Does that make sense? All right. You sure? Okay. Let's practice some zero product property. What are the solutions of each equation? All right, cool. I got x plus 1 times x minus 5 equals 0. So I got to use my zero product property. Every single factor must be set equal to 0. So x plus 1 will equal 0. X minus 5 will equal 0. My solutions, x equals -1 and 5. I'm skipping the work because I know you know how to do it. Just in case for anyone out there that just got stuck, subtract 1 to both sides. X equals -1. Add 5 to both sides. X equals 5. Okay? Next, 7n minus 2 times 5n minus 4 equals 0. I want to find the solutions. I use the zero product property. 7n minus 2 equals 0. And 5n minus 4 equals 0. Add 2 to both sides. Divide by 7. So n equals 2/7. Add 4 to both sides. Divide by 5. So n also equals 4/5. So my solution here for this guy, n equals 2/7, comma 4/5. Again, what does that mean? That means that some parabola intersected the x-axis at both 2/7 and 4/5. Pretty simple, right? All right. Let's continue. What are my solutions here for C? What do I got to do here? How do I solve this? I set each factor equal to 0. Very good. So I got 2x plus 1 equals 0, and x plus 14 equals 0. So in this case, x will equal -1/2, and also -14. Last but not least, I give you factors that are set equal to 0. I say solve for this equation. Use the zero product property. Set each factor equal to 0. Set each factor equal to 0. And then solve for x. So in this case, it's going to be -3/2 and 4. Boom. Done. Does that make sense, my friends? All right. Now, Let's put it together. And believe it or not, this is practice for tomorrow's test. Believe it or not. You're not going to solve, but what do you have to do before you solve these? Factor them. And isn't our test on factoring? So this should be a nice review. Okay, my friends, I got x squared plus 8x plus 15 equals 0. The only way to solve this is to factor. Go for it. What is it, my man? And that's going to be a nice easy one. X plus 5, x plus 3 equals 0. Now, I have to solve for x. So I use the zero product property. Each factor gets set equal to 0. I know I sound like a broken record, but I want to make sure you got this. So in this case, x will equal -3, -5. Again, I don't want to be rude, but pay attention. This means that at -3 and -5, a parabola is intersecting at those 2 points on the x-axis. You feel me? Yes, sir. Thank you. What do you mean it doesn't matter what order you put it in, Papo? Oh, it doesn't matter if you put -3 or -5 first? No, sir. I thought you meant on the graph. On the graph, it definitely does matter. All right, let's just continue. Let's factor and solve, my brothers. What does that factor out to? Boom, -4 and +5. Excellent. So, in the end here, when I do the zero product property, I got to set both equal to 0 as I'm doing, and you're absolutely right. The answer is 4 and -5. Okay? What does that mean? That means that the parabola is intersecting the x-axis at 4 and -5. Next, let's factor. What times what is -14? But when I add together is -5. And -7, n plus 2. Zero product property. You set every single factor equal to 0. So in this case, m equals 7 and -2. Again, I know, broken record. That means that this parabola intersected the x-axis where? At 7 and at -2. You sure you guys see this, right? You're visualizing this because this is important. A lot of teachers just teach it, and you know, God bless them, they do a good job teaching it, but everyone walks away going, look, that's great, but what do those numbers mean? Now you know what these numbers mean. Okay? So here we got a cubic method. We can't factor any GCF out. So I got 2x, a times c. My new c is 36. What times what is 36? But when I add it together is 15. -12 and -3 is exactly right. Artificial factor. So I got x minus 6 and 2x minus 3 equals 0. Zero product property. Every factor must be set equal to 0. So x minus 6 equals 0. 2x minus 3 equals 0. So x equals 6 and 3/2. And again, last time, what does that mean? That means that at the 3/2, at 1.5, and at 6, this parabola is going through those 2 points on the x-axis. Does it make sense? All right. What are the solutions? All right, let's do this. Now, whoa, wait a second, Maura. Whoa. Wait, what's going on here? That's not a trinomial. So what? The first thing I always want to do when I'm trying to find these x-intercepts, don't I have to make y 0? Because is that the definition of x-intercepts? So how do I make this a 0, my brothers? Thank you. I love it. Good job, guys. So then this is going to be 4x squared minus 39x, right? Okay, whoever said yeah, thank you for proving that you're not paying attention. That is not, no, there's no waiting there. There's no but or if. I love you all. I played a trick on you and you fell into it. No, you cannot add those because they're not like terms. So sorry to be sneaky, but come on now. You know, that was a good one though, right? I got you. I got you guys. That's good. All right. Great. Thank you. Cubic method. Let's do this because I cannot factor anything out of, I can't factor a GCF out. Okay, so 4 times 8. Wow, thank you. Negative 72. What times what is negative 72? But I have to go is negative 21. That's a good one. Excellent. Excellent, man. Negative 24 and positive 3. Wow, that is fantastic. Artificial factor of 4 here. So I got x minus 6 times 4x plus 3 equals 0. Guys, I'm going to erase this for a second, can I? Because I'm running out of space. Okay, sorry. Thank you. Bless you. All right, now, how I set each of them equal to 0. X minus 6 equals 0. 4x plus 3 equals 0. So x equals 6 and negative 3 fourths. Make sense? Okay, number 2. Let's factor and solve. I want to solve this equation. So I'm going to first have to factor it. What times what is negative 54, but when added together is positive 3? Positive 9, negative 6. Excellent. Zero product property, x plus 9 equals 0. X minus 6 equals 0. Bless you. X equals negative 9 and positive 6. Tell me out loud so I don't have to be a broken record. What does that x equals negative 9 and 6 mean? What does that mean? Excellent. I heard that in that jumbled stuff. I heard it. Those are the 2 points that the parabola intersects at the x-axis. Excellent job, my friends. Awesome. Great job. Okay, how do I set this equal to 0, my brothers? Okay, by chance, does anyone recognize what kind of a trinomial this is? Very good. That's a perfect square. What's the square root of that? That's a perfect square. What's the square root of that? What's 7 times x times 2? It works. So it's x plus 7 squared equals 0. Now, don't let that squared scare you. How do I get rid of a power of 2? Square root it. Can't I square root it? Then I got x plus 7 equals 0. Or, some of you looked at me like I just, cursed you out. So, why don't we do this? You know it's x plus 7 squared. Doesn't that equal x plus 7 times x plus 7? So it's just going to be x plus 7 equals 0. You don't have to repeat it. So x equals negative 7. So that means that for this one, it only hits, the parabola only hits it at one point, right there. Does that make sense? Cool. Yes, sir? It's both the same factor. X plus 7 and x plus 7 is still going to give you x minus 7 for both. X equals negative 7 for both, Papa. Why would you have to rewrite that? It's the same number. Thank you, my brother. Okay. Last but not least. Can I factor GCF out? No, you cannot. Okay. What times what is negative? No. 72, negative 72. What times what is negative 72? We're out together is negative 21. Did we just do this? Did we just do that one?
No, there was 4x and 18.
All right, well, whatever. It's 24 and 3, right? Negative 24, positive 3. So, yeah, take out a 2. So, it's x minus 12 times 2x plus 3 equals 0. So, when I set them both equal to 0, x equals 12 and negative 3 halves. Make sense? Mickey Mouse. And we're done. Excellent. Thank you very much. I hope you learned a lot.